we have a hula hoop that we're rolling up a ramp. Its initial velocity is 4.1 meters per second, and it goes up a height of 1.5 meters. What is its final velocity? In this case, what we're going to do is use conservation of energy. We have rolling energy, we have gravitational potential energy, and we have kinetic energy. So energy initial equals energy final. So we have gravitational potential energy, mgh initial, plus kinetic energy of the hula hoop, the energy of motion, 1/2 mv0 squared, plus our rolling energy, 1/2 I omega squared. And that has to equal our final kinetic energy, our final total energy of mgh final, 1/2 mv final squared, and 1/2 I omega final squared. Now, if we look at this, we can tell right off the bat that the initial height is 0. We define our 0 down here. And so we can say this mgh term is just 0. So we have kinetic energy. We have 1/2 mv0 squared. V0 we know. We don't know m. 1/2 I omega squared. We're going to have to figure out what I and omega are. We know I for a hula hoop. It's a hoop with all the weight distributed around the edges. So I is equal to mr squared. So instead of I, we now have mr squared we could put in there. Omega, we have a relationship that relates omega and a velocity in terms of radius. So the tangential velocity is equal to r omega. So omega can just be v over r. So we have v over r that we can put in for omega. So for this term, 1/2 I omega squared, 1/2 I is mr squared. Omega squared is v over r. So we have v over r squared. That equals mgh, our final height, which we know is 1.5, plus 1/2 mv final squared, plus our last term, 1/2 I omega final squared. Same thing as before. We can plug in for I, we can plug in for omega. 1/2 I, again, is mr squared. mr squared. Omega final is v over r. This is a different v this time. This is final v. Vf over r squared. In this case, in our initial case, we had v0. So now we can do some canceling. We look, every term has a mass in it. So we can divide everything by mass. Mass cancels out. So let's rewrite this. We have v0 squared over 2, this term. This term, we have v0 squared. We look, the r squared on the bottom cancels with this r squared here. So we're just left with the 2 from here. So we get v0 squared, r squareds cancel, equals gh 1/2 vf squared, so vf squared over 2. And in this case, again, we're going to get the r's canceling. R squared cancels, so we get v final squared over 2. So these are fractions we can add up. v0 squared plus over 2 plus v0 squared over 2. 1/2 v0 squared plus 1/2 v0 squared is just v0 squared equals gh. Same with the vf plus vf squared. All we're trying to do is calculate v final. So I take my GH to the other side. minus GH. Take the square root of both sides to get rid of this squared. So, initial velocity of 4.1 squared minus G, gravitational constant, 9.8, height, 1.5, square root, gives us a final velocity, 1.45 meters per second. Final answer.